Now we have 24.2 currents under the surface. Two objectives here: describe the flow of density currents and then identify factors that affect the density currents of ocean water. Two vocabulary terms: density current and upwelling. Make sure you get those in your lab notebooks before we begin. Key idea here: deep ocean currents are driven by properties that determine the density. So deep ocean currents are driven by density of water, such as salinity and temperature. Now, density is what drives ocean currents under the surface. When an area of water becomes more dense than the waters around it, the denser water moves beneath the less dense water, forming a flowing current called a density current. Now, at what locations, follow along the blue line and the red line all the way across the globe. What locations do deep currents rise to the surface? If you answered the Indian Ocean and North Pacific, you're correct. And where do the surface currents sink to become deep currents? That's right, in the North Atlantic. Now, density currents can flow vertically or horizontally. Temperature and salinity are two factors that influence the density of an area of water. So let's check out the density currents from polar water. Now, these are deep currents from polar areas that flow through the Atlantic Ocean. The depth of each current depends on its density. So as you see on the bottom, we have the equator right in the middle, and we have the south, the Antarctic, the South Pole, and then we have the north getting closer to the North Pole, or the Arctic. Now, how far does the North Atlantic Intermediate Water extend? North Atlantic Intermediate Water. That's this water right here. It goes from about 45 degrees north down to about 10 degrees north. Now, which current is the most dense, or the densest? That's right, that's bottom one, the Antarctic bottom water. Now, which currents are closest to the surface water? The North Atlantic Intermediate Water and Antarctic Intermediate Water. Good. Now, the densest seawater comes from polar regions. The density of water is also high in areas of high evaporation. Density currents are caused by evaporation. Now, why is the salinity of the water in the Mediterranean higher than that of the water in the Atlantic? So the Mediterranean has a salinity of about 40 psu. The Atlantic Ocean is less dense and it has a salinity of 35 psu. This is the Straits of Gibraltar. It's called the Gibraltar Sill. And notice that there is a two-way flow of water crossing over the sill. Mediterranean underneath and the Atlantic Ocean above. So again, the question is, why is the salinity of water in the Mediterranean higher than that of the water in the Atlantic? Well, because the climate is hot and dry, water in the Mediterranean evaporates at a higher rate, leaving salt behind. So again, going back to our processes, evaporation and freezing both leave salt behind, so it increases salinity. Now, how does salinity affect the density of water? The higher the salinity, the greater the density. Why do surface currents from the Atlantic flow into the Mediterranean? Now, the surface currents bring in less dense Atlantic water up here near the surface to take the place of the dense water that flows out from the Mediterranean. Right underneath here, it's in a darker blue. Now, an upwelling is a type of density current in which surface water is displaced and cold, dense water rises to replace it. So surface water is displaced, the surface winds push that water out of the way, and cold water upwells to the surface. Now, El Nino is an ocean current that brings unusually warm water to the west coast of South America. These currents occur on average about every 4 years. During El Nino years, the trade winds that drive surface currents off the coast weaken, and as a result, the upwelling that normally occurs near the Peruvian and Chilean coast is reduced, greatly harming those countries' fishing industries. Now, upwelled water contains large amounts of nutrients that phytoplankton need, this water right up here, in order to grow. Phytoplankton, the microscopic organisms that are the basic food for all the other living things in the oceans, thrive in areas of upwelling. Animals higher in the food chain can live with phytoplankton in areas of high upwelling. As a result, these areas are usually major commercial fishing areas. That's it for 24.3 or 24.2. Next up, 24.3.